Welcome students. So today we are talking about vectors and scalars. So before we go into this topic, first try to understand some of the basic things. What is a physical quantity by definition? So a physical quantity, first thing is it's actually a measurable property. Measurable property of what? Of a physical system. And it has a numerical value. Okay. Also, it has a unit. Now, we will use one term rather than using numerical value. So I'm going to write it here, which is magnitude. Okay. So rather than using the word numerical value, I'll say magnitude. So a physical quantity is a measurable property of a physical system. What could be a physical system? Anything. Let's take this pen. Okay, a pen is also a physical system. I can throw it, it will have some velocity, or some speed, it can travel some distance. I can apply some force. So this is a physical system, and I can measure the velocity or the speed or the force applied on this system. It could be directly or indirectly. What is directly? Directly means, let's say I want to measure the mass of this. So I can measure it directly. But to measure the velocity, I need something else. I cannot get that directly if I throw this. Okay. So I need to also know what is the force that I have applied, what is the acceleration that is gained. So all those things I need to know. Some of the properties I cannot get the values directly from a physical system. Numerical value or magnitude is something which defines that value. So for example, the mass of this pen, let's say 50 grams. Okay. So 50 is the magnitude of it, and it has a unit. So gram is the unit. So that is what a physical quantity means. If I say a force of 5 Newton, so 5 is the numerical value or magnitude, and Newton is the unit. Okay, so we understood what a physical quantity is. Now think of it, what is missing from this physical quantity? So one thing which is for sure is missing from this definition is the direction. What if I don't have direction for some of the cases? Let's take the concept of when direction is not there at all. What can happen? Many things. You will not have a navigation app. Okay. There will be no sense of direction, so all the transport vehicles won't work. All the historic sailors that actually have traveled from one place to other exploring things won't have happened, even including the modern devices which includes semiconductors like laptops, mobile phones, internet. It will all be in a mess. Okay, nothing will work. So direction for some of the physical quantities is very important. So that is all about the what is a physical quantity. Okay, and why we need to define it in terms of vectors and scalars. So vector is something which has magnitude plus direction, and scalar is something which only has magnitude. Think in terms of that I apply a force on a body. If I don't have the direction, I won't know in which direction that body will move. So for some of the properties, I need to define a physical quantity in terms of a vector. Okay. The question will be, till class 9th and 10th, we never used it. We never had to use vectors or direction. We just knew that, okay, it will move in a particular direction and we will solve the problem. Yes, that's an issue because you were only solving the problems in one dimension or in some of the cases in two dimensions, but very simplified. For example, a circular motion. You did it in two dimension, but you only had one formula for it and you were able to solve the issues. However, when you move to class 11 and 12th, you will see that most of the issues or problems that we will work on will have two-dimensional or three-dimensional problems. And direction for those cases is very important when you have multiple actors acting on a physical system. Multiple actor means there could be a force applied externally, internally, there could be some kind of exposure to some kind of energy. So all these things can actually impact the physical behavior of a physical system. And that is where these vectors come into play. Now, considering why we use term vectors and scalars, very obvious. Most of these terminologies that we actually read are coming from Latin words. So vector directly coming from a Latin word, which means carrier of a quantity from a point to point. So that is the reason we just use it. And for scalar, it comes from a word scala, which is about steps or ladders. However, think in terms of a scale. You can scale something up, you can scale something down. It is only for scaling and multiplying and addition, whereas the same things can be done here, but the operations are not numerical. Like 2 plus 2 is not 4 here. 2 plus 2 for a vector could be 0, 2 plus 2 could be 3, or anything up to 4, right? How do we actually mention or denote a vector? Okay, so that is called as vector notation. Vector notation is what? If you want to represent a vector graphically, you just need to put an arrow here, and this is called as the tail. This is called as the head. Okay. So tail is actually the origin point where this vector is originating. Okay. When you say origin, don't confuse this with the origin of a coordinate system. For example, Cartesian coordinate. In Cartesian coordinates, what do you have? Let's say this is x, this is y, and when we say origin, we say 0, 0 is the origin. Not always the case with vectors. Okay, for example, I can have a force which actually is pointing like this, so the origin of the force in that case is here, which is not 0, 0. Okay, the head denotes the direction, and the length is the total magnitude. Got it? Right. So this is for a graphical representation. How do we represent it in variables? Let's say there is a vector called x. Okay. The only thing is you are denoting it as x. You just need to put an arrow on top of it to denote it's a vector. So if I say normally, if I say x, that's a scalar. But if I just want to talk about magnitude of a vector, I will have to do a mod, which is only the magnitude. So this is actually only the magnitude of a vector, whereas this is a scalar which doesn't have an arrow. Let's go through quickly what are the variables that you have already gone through in 10th. So velocity is a vector, acceleration is a vector, then you have displacement is a vector, force, momentum, all these are vectors. How about scalars? Distance, speed, time, mass, work, energy, all these are scalars. Okay.